So chemical equations and stoichiometry. Chemical equations is what we use to represent a chemical change. So we have our reactants, which are our initial substances, and after the chemical change happens, we're going to have new substances, which are the products or what is being formed in the chemical change that is happening. Now, stoichiometry is everything that has to do with quantities, and that information that we're getting comes from the balanced chemical equation. So we can use these two together as long as the chemical equation is balanced. And having a chemical equation that is balanced means that you have the same number of atoms for each element on both sides of the arrow. So if you have 2 atoms of carbon on the reactant side, you should have 2 atoms of carbon on the product side, and that means that the carbon is balanced in the chemical equation. So stoichiometry deals with quantities, which are amounts, and for our class, we're using amounts in one of 2 units. We have amounts in mole or amounts in grams. So we can actually use stoichiometry to find out amount in grams or moles for any substance in a chemical equation. So we can use a chemical equation to find out the molar relationship for all of your reactants and products in that chemical equation. And all of that molar relationships is what we use right here. That's the stoichiometry of the equation. So I'm showing you here the reaction for the formation of water, hydrogen plus oxygen giving you water. And I have my coefficients in different colors for each substance that you have in the chemical equation. So we read this equation here as 2 moles of a hydrogen react with 1 mole of oxygen to form 2 moles of water. So the molar relationship, I have 2 things related, okay? For each one, it's 2 things. I have the molar relationship between the hydrogen and the oxygen. So every 2 moles of hydrogen are reacting with 1 mole of oxygen. 2 moles of hydrogen are forming 2 moles of water. 1 mole of oxygen is giving you 2 moles of water. So all of these molar relationships, I'm getting them from the equation. I'm going over this one and that one. That's the first one. Hydrogen and the water, this one and that one. And then oxygen and the water is this one related to that one. So we can actually use this molar relationship to, if you're given grams of a substance, you can find grams of a different substance. And what that means is that, for example, if you're given any amount of oxygen in grams, you can actually use the molar relationship between oxygen and, let's say, hydrogen to find out how many grams of hydrogen you need to react with that amount of oxygen that you have. Or the simpler type of problem, which is this one, which are the first ones that we're going over. You can relate amount in moles for a substance with amount in moles of a different substance. So for example, if you have any number of moles of oxygen and you want to know how many moles of hydrogen you need to react with that specific amount in moles for oxygen, you can use this molar relationship here to find out your number. So the coefficients are going to be used as conversion factors. That's your molar relationship. So I'm using all of my coefficients to relate all of the substances that I have in my chemical equation And then we can actually use those molar relationships as conversion factors. So everything that I'm doing, it's a conversion from a given number of moles to a number of moles for a different substance. So looking at your balance equation is the same one. Every 2 moles of hydrogen that react with 1 mole of oxygen, it's forming 2 moles of water. And that's what you have here. Now, you can use this here as a recipe to find out any amount that you need. So I have one example here. You have 2.2 moles of hydrogen, and you're trying to find out how many moles of water you can get with that specific amount of moles of hydrogen. The problem is telling you that you have enough oxygen. What that means is that, look, for every 2 moles of water that you're forming, you need 2 moles of hydrogen, 1 mole of oxygen. Here, you're not giving an amount of oxygen, you're just giving an amount of hydrogen. So you have plenty of oxygen to form or to react with this hydrogen to get the water. So whenever you have a type of problem like this one, where you're given amount of a reactant, H2 reactant, and you want to know how many moles of your product you want to form, you have hydrogen and H2O. The one that you're trying to get is H2O. That's what the problem is asking you. This here is 2 moles of H2O. And that's what you're trying to find out. So I'm just copying my coefficient, and that coefficient means moles, so that's 2 moles of H2O. And the two things that you are trying to relate is the moles of H2 with the moles of the water. So you have 2 moles of H2O, and then for the hydrogen you have also 2 moles. This is your conversion factor. Okay? You can use this conversion factor as 2 moles of the water on top and 2 moles of hydrogen on the bottom part, like the one that I have here, or the other way around. You can have 2 moles of H2 over 2 moles of H2O. But this is the one that you have, that you need, because you're trying to get moles of H2O, and what you're given is the moles of H2. So the number that you have is 2.2 moles of H2. And if you do that number times your conversion factor here, you will get moles of the water, because H2 it's canceling out with H2. And what you have left is the moles of the water. So 2 over 2 is 1, and that will give you 2.2 moles of H2O. So you can check your reaction and the problem that you have. In your reaction, if you have 2 moles of H2, you are going to get 2 moles of water. In your problem, if you have 2.2 moles of H2, you're going to get 2.2 moles of water, because for every 2 of this one, you're getting 2 of your product. So whatever number you have, it's going to be the same number that you have for your product, because your coefficients are the same, and you're going to get 1 here. If you have 100 moles of H2 and you want to know how many moles of water you can get with that amount of moles for H2, if you have an excess of oxygen, which is your other reactant, from 100 moles of H2, you will get 100 moles of water, because your coefficients or your conversion factor here is 2/2 from your reaction. Now the second one that I have here, you're trying to find out how many moles of H2 to form 4.64 moles of the water. And this is still assuming that you have enough oxygen present. Two problems assuming the same thing. So now what it's given is the number of moles of water. In this one, that's what you were calculating. You were given like the moles of one of your reactants, the other one is an excess, and you're getting how many moles of the product you can get. Now in the second one, you have the amount of your product in moles. You have 4.64 moles of H2O. So that's the given amount, which is what you always use to start your problem. And you're trying to get the moles of H2. If you're trying to get moles of H2, whenever you're using your coefficients as conversion factors, what you're trying to get goes on top. So you're trying to get moles of H2, that should go on top. And what you have should be on the bottom part of your conversion factor. So what you have is the moles of the water. So I'm going to write down and the amount, it's the number that you have in your chemical equation or that coefficient. For H2 you have 2, and then for the water you have 2. That cancels out with that, and what you have now is the moles of hydrogen. To get 4.64 moles of water, you need 4.64 moles of hydrogen. So this is what we do if you're given amount of any reactant or any product in moles, and you're trying to find out amount of anything else in that chemical equation also in moles. Okay? You use your coefficients here to write down a conversion factor, and your conversion factor should have always on the top part what you're trying to get, and on the bottom part what you're trying to cancel out, which is the same thing that it was given. Okay? So now this is not assuming that you have an excess of oxygen or anything. Okay? Those with the excess for oxygen, one of your reactants in excess were the first two problems. Now let's see what you have, and I was using the red for H2. That's the given. And now you're actually trying to calculate amount for oxygen. So let me copy the reaction red, blue, and purple. H2 plus O2 giving H2. Okay. So it's the same reaction that we were using. So you're given your moles of hydrogen and you're trying to find out moles of oxygen. So in the previous problems, you had an excess of oxygen. So you were not worried about the amount of oxygen because you had a lot of that. In this one, you're actually trying to calculate, okay, if you're doing this reaction to get the water and you have 8 moles of hydrogen, how many moles of oxygen do you need for those 8 moles of hydrogen to react entirely, so you don't have any hydrogen left? So you're always going to start your problem with the given amount, which is your 8 moles of H2 and now you're going to follow that number with your conversion factor from that you're getting from your chemical equation, from your balanced chemical equation. So you're trying to calculate moles of O2. So that's what you need on the top part of your conversion factor. And that's just 1 mole. So you don't have a plural word because it's just 1. And that's from your reaction. And then you're trying to cancel out moles of H2. Okay? And for that one, you have a 2. So this is 8 times 1 divided by 2, okay, which is just a half of your amount of hydrogen. Those two are canceling out because it's moles of hydrogen, and you're getting a number in units of moles of oxygen, which is going to give you 4. So if you have 2 moles of hydrogen, you need 1 mole of oxygen to react entirely with your 2 moles of hydrogen to get your 2 moles of water. And so it's 2 of hydrogen with every 1 of oxygen. So if you have 8 moles of hydrogen, which is 4 times this amount here, you will need 4 times the amount that you have of oxygen in your reaction. So that's why you have 8 moles of hydrogen with 4 moles of O2. If you need 2 moles of 1 mole of oxygen per every 2 moles of hydrogen, you will need 4 moles of oxygen for every 8 moles of hydrogen. That's what you're calculating. Now I have a more interesting problem here because in this one, I'm giving you amount for both reactants. Everything that you did were amount of 1 and you were getting amount for another one. But in this one, you want to know how many moles of water you can get if you have 8 moles of H2 and 6 moles of oxygen. So in this problem, you don't have excess of any of your reactants. Your given amount for each reactant listed in your reaction, you have hydrogen and oxygen, and the problem is asking you, okay, if this is your reaction, your recipe, if you react 2 moles of hydrogen with 1 mole of oxygen, you're getting 2 moles of water. So now this problem is asking you, okay, if instead of having 2 moles of hydrogen and 1 mole of oxygen, you have 8 moles of hydrogen and 6 moles of oxygen, how many moles of water can you get? That's what we need to figure it out. So I'm going to do my calculation in a similar way to what we did before, but I'm going to have 2 separate calculations. 1 for each reactant. That's how we solve this type of problem. I have 2 reactants, so I'm going to find out how many moles of water can I get with this amount of hydrogen, and then in a separate calculation, I'm going to find out how many moles of water I can get with this amount of oxygen. So I'm going to start with my hydrogen, and the given amount for the hydrogen is 8 moles. And I'm trying to find out with 8 moles of hydrogen, how many moles of water can I get? Okay? So I'm relating my hydrogen with the water. And I'm trying to get the water, which means that that one should go on top. And I'm trying to cancel out the moles of H2, so that's the one that you need. So we have 2, we have 2. So for every 8 moles of hydrogen that you have, you can get 8 moles of water. So I'm done with my first reactant. With the moles of my reactant, the first one here, I calculated how many moles of water I can get. So if you have 8 moles of hydrogen, you can get 8 moles of water. Now I'm going to do the same thing, but in a separate calculation with my second reactant. So my second reactant is 6 moles of O2. And I'm trying to get moles of the water. So moles of the water is right there. And you have moles of oxygen on the bottom part, because that's what you're trying to cancel out. So your coefficients for O2, that's a 1. And for the water, that's a 2. And you're going to have now 6 times 2 divided by 1. That's a total of 12 moles of water. So you have 2 reactants, and you're calculating amount of water that you can get with each reactant. With hydrogen, you can get 8 moles. With oxygen, you can get 12 moles. And you need to answer just one question. It's one possible amount of water that you can get. It's not that you can get 8 moles and 12 moles, or that you can get the addition of these 2. It's one or the other. So I'm going to show you something to help you figure it out. I'm writing my amounts here, the given amounts. You are given 8 moles of hydrogen and 6 moles of oxygen. So I'm writing it down. Hydrogen, it's H2. So I have H2, 2 H's, HH, and the same thing 8 times, right? This is H2, 1, 2, 3, 4, 5, 6, 7, 8 times. And you're given 6 moles of O2. So I have 1, 2, 3, 4, 5, 6 O2. So if you check your number of atoms for each individual reactant, 8 moles of H2, that's a total of 16 hydrogens, and then 6 moles of oxygen, that's a total of 12 oxygens. Now, looking at your water molecule here, look, your water molecule, each water molecule, H2O, is 2 hydrogens and 1 oxygen. So you need 2 hydrogens and just 1 oxygen to have one molecule for water. So if you look at your given amounts here, with 8 moles of hydrogen that you have, you need 2 hydrogens in each water molecule. With 8 moles of hydrogen, you can actually get 8 moles of H2O, which is what you calculated here, because in every molecule of water you need 2 hydrogens. Now, with your oxygen, every water molecule contains just one oxygen atom. So you have 12 oxygen atoms here, which means that with these 12, you can get actually 12 water molecules. But to get 12 water molecules, you need more than the amount of hydrogens that you have. With the oxygen, you can get 12 because you have 12 oxygen atoms, and in each water molecule, you need just one oxygen atom. But the hydrogen, for you to use all of these oxygen atoms, the 12 of them, you will need 24 hydrogens, because for every water molecule, you need 2 hydrogens. So with the given amounts that you have, 8 and 6, the maximum number of water molecules that you can get is this amount right here, 8. And I'm going to write it down. That's 1, 8. Eight water molecules, and if you have 8 water molecules, you have no hydrogen left. You're using all of your hydrogen to get these 8 water molecules here, which is what you calculated. With 8 moles of H2, you can get 8 moles of water. 1, 2, 3, 4, 5, 6, 7, 8. Now, your oxygen, you're using 1, 2, 3, 4, 5, 6, 7, 8. And you have 12 available. So your oxygen is in excess. The hydrogen is actually limiting the amount of water molecules that you can get. You have enough hydrogen to get 8 moles of water. You have enough oxygen to get 12 moles of water, which is what you calculated. You cannot get 12 moles of water because you don't have enough hydrogen. The amount of hydrogen that you have, it's enough to get 8. You cannot get more than that because there's no more hydrogen left. Okay? So whenever you have a problem like this, where you're given amount of 2 reactants, right, and you're trying to find out how many moles of a product, which in this case is the water, you're going to do 2 separate steps, one for each reactant, and you're going to calculate how much product you can get with each one. And you're going to choose the one that gives you the smallest amount of the 2. You have enough oxygen to get 12 moles of water, and you check that because you have 12 oxygen atoms and you need 1 oxygen atom in your molecule for water. But you don't have enough hydrogen to use up all of the oxygen that you have to go all the way to the 12 moles of water. So always the one that gives you the smallest amount of product, that is the one that is telling you how much product you can actually get from a chemical reaction. So you can get 8 moles, only 8. And now I have some definitions here, and then I'm going to show you the same thing but with an easy thing for you to see. So in the previous problem, you calculated that the amount of water that you can get with 8 moles of hydrogen and 6 moles of oxygen, that's 8 moles of water. Okay? That amount of water right there, that number has a name. That's a theoretical yield. The theoretical yield, it's a number. That's the maximum amount of product that you can get from this reaction because you don't have enough hydrogen to keep reacting with the oxygen. Okay? So that's your theoretical yield. And the reactant that it's giving you, that theoretical yield, is known as the limiting reactant. Limiting reactant is a reactant, hydrogen in this case. Theoretical yield is an actual number, an amount, and that amount can be in moles or in grams depending on the type of problem that you have. So I have my definitions here for theoretical yield and for your limiting reactant. Okay? It limits the amount of product. If you look at your problem for hydrogen, you can get 8 moles of water, but with the amount of oxygen that you had, you can get up to 12 moles of water. So the hydrogen, it's actually limiting the amount of product that you can get. You cannot go all the way to 12 moles of water because you don't have enough hydrogen to get 12 moles of water. You have enough hydrogen only to get 8 moles of water. So the hydrogen is actually limiting the amount of product that you can get. And in that specific example, the oxygen was in excess because you had oxygen left, right? You have enough oxygen to go all the way to 12 moles, but the actual amount of product that you can get is just the 8 moles that you can get with the amount of hydrogen that you have. So now I have here a recipe to prepare burgers, and a simple thing. You have 1 bun, 1 cheese, 1 patty, and if you put all of them together, you're going to get 1 burger. So your coefficients are actually 1, 1, 1, and 1. Okay. So this recipe is the same thing as your chemical equation. Your coefficients, it's how many you have, and then which ones you need to combine, how many of each one to get your product. So that's my recipe, which looks like a chemical equation if you put the words here, right? Now, if in this equation here you have, you are going to assume that I have plenty of the burger buns, plenty of the patties, but I only have 24 slices of cheese. If I have everything, enough of everything for the burger buns and the patties, those are not limiting the amount of burgers that I can prepare. But I only have 24 slices of cheese, and I need 1 slice of cheese for every burger that I'm preparing. So if I have 24, using my recipe here, for 1 burger, I need 1 cheese. That will give you 24. I'm sure you knew that already. Okay? So that's it. You have plenty of these two, and this one is limiting the amount of burgers that you can get. So now, let me move this. The same recipe, same thing. But now I have limited amounts for all of my ingredients. I don't have enough or plenty patties or burger buns. I have my limited amount of ingredients listed here. I have 4 burger buns. I have 6 slices of cheese, and I have 5 burger patties. So with these ingredients that I have here, how many burgers can I prepare? So maybe someone is thinking that you can add all of them together and that will tell you how many burgers you can get. But that's not how this works. Not for this example, not for any of the examples that we're going to be doing. Ingredients right here, right? This is your recipe and this is the amount that I'm giving you. I'm telling you that you have 4, 6, and 5. These are my ingredients or my given amounts. Now, with my recipe, I can find out my conversion factor. And I'm trying to calculate how many burgers. So I need, with my recipe, I have for every burger, I need 1. 1 and 1. With my slices of cheese, to get 1 burger, I need 1. And the last one, or the third ingredient or reactant that I have here, is my burger patty. So for every burger, I need 1 patty. So that's going to give me 4 times 1 divided by 1. That's just 4 burgers. For the second one, I have 6 times 1 divided by 1. That will give you 6 burgers. And then for the third one, with 5 patties, that's 5 times 1 over 1. That's 5. So I have 3 possible amounts, right? With the buns, I can get 4. With the cheese, I can get 6. And then with the patties, I can get 5 burgers. But the actual amount of burgers that you can get is this number here. Just 4. You have buns enough for 4 burgers. You have enough cheese for 6. You have enough patties for 5. But you don't have enough buns to get 6 or to get 5 burgers. You have enough buns to get only 4. So 4 burgers will be your theoretical yield. In theory, if you have 4 buns, 6 slices of cheese, and 5 burger patties, in theory, you can get 4 burgers. If you can get only 4 burgers, you can get only 4 burgers because this one here, it's limiting the amount of burgers that you can get. You see, you have enough cheese to get 6, enough patties to get 5, but you don't have enough buns to prepare 6 or 5. So that's limiting the number of burgers that you're getting. And then the third one, the actual yield, right, is what you actually get. If you're doing a chemical reaction, you're expecting to get certain amount of product based on the amount of reactants that you're mixing. But sometimes you spill any of your reactant when you're transferring. If it's a solid, you weigh that one, and when you're transferring, some of the solid stays in the original container, so you're not transferring the whole amount. So things happen, and what you get from an actual experiment sometimes is not what you're expecting. So what you actually get is the actual yield. Okay, so the actual yield is the amount of product that you're getting from a chemical equation or for a chemical reaction. So to give you an example of the actual yield, with the amount of ingredients that I have, I can make 4 burgers, right? That's my limiting reactant, and that's my theoretical yield, 4. But if I drop one of my burgers on the floor, now my actual yield is not 4 because I dropped 1. So my actual yield is 3. I was expecting to have 4, but I'm dropping 1 on the floor and I'm not going to eat that one. So now I only have 3. So that's the actual yield, right? So I have 2 problems here for you to solve. I'm going to write down the answer. Okay? You're going to solve it and I will give you the answer so you can check your own problem. So you're given moles of calcium and you're trying to find out moles of oxygen. And I didn't write it down, but in front of your oxygen, the coefficient is 1. If it's not there, it's just 1. So in this one from calcium and you're getting oxygen, and then in the second one you have amount of your product, assuming that you have a lot of calcium, and that's the given one. Okay? So you're going from oxygen to amount of your product. So 2.87 moles of oxygen, how many moles of calcium oxide you can get? So that's the answer for each one. Do your calculation and check your numbers. And then for this one, you're given amount of calcium, one of your reactant, amount of oxygen, the other reactant that you have, and you want to know the amount of product. And this should say amount in moles of calcium oxide. How much of your product you're getting if you're mixing 17.14 moles of calcium with 12.43 moles of oxygen. And that's your answer.